Hi, so we're looking at squares today, and our first problem is going to just be 180 minus 5 times that dot is multiplication 2 squared. And this is simply a order of operations problem, and so PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. These two and these two are on the same level, just left to right. So go and compute that. Now what you should have done was squared the 2 first, and we would get 4. Then we're going to uh, just rewrite the whole thing. And then we need to do 5 times 4, get 20. 180 minus 20 is 160, and we have solved the problem. So if we do the same thing, order of operations again, we need to find the value of 2x plus 5 squared, and this is when x equals 3. So what we need to do is substitute that 3 in for x and then see what we get. And when we do that, well, you go and try that out. All right, so now we have 2 times 3 plus 5, and that's all squared. So 2 times 3 is 6 plus 5 squared. And 6 plus 5 is 11, so 11 squared. 11 squared is 121. These aren't that bad, just have to be systematic. So then there's kind of this next problem is looking at what happens if we have negative 12 squared. So if we do this problem, this whole thing is squared. So, and that's what a square is. We're multiplying whatever is in the parentheses or right before it that many times. So negative 12 times negative 12. And you may not be familiar with negative numbers yet, but you soon will be. And if we multiply a negative times a negative, we end up with a positive. So this is going to become positive 144. Now, if we did so this problem is exactly the same as if we did 12 squared. We would get 12 times 12. It's the same result because we end up with 144. But I want you to think about what would happen if instead of this we had numbers not within the parentheses. So if we do negative 2 squared, you can do that problem. So go and try that one out. And you should have gotten negative 2 times negative 2, which equals 4. So this simplifies to 4. Now, if we have negative 2 squared, you see this slight difference here, then what does this equal? Think about that one. And what you should have gotten was the 2 is squared, but the negative is not. And so we end up with negative 4. And then, so I have one more problem, and we're going to look at this one. So if we have this expression 2x squared plus 3x plus 4, and then we substitute in x to be negative 2, now we have every time we're substituting in x, we kind of put it in parentheses because this x could be anything, and so this negative is going to be squared in this instance. So go and try that one out. And so you should have put negative 2 squared plus 3 negative 2 plus 4. And when we have parentheses next to another number, we know that that's multiplication as well. So, but we have to follow order of operations again. We get that this is 2 times 4 plus 3 times negative 2 plus 4. And then we're going to get 8 here plus negative 6 plus 4. 8 plus negative 6 plus 4, we end up with positive 6. If we do another problem, we're going to look at a little further down the page. So why are these two equal? X times 125, sorry, 8 times 125 squared is equal to 8 squared times 125 squared. Well, go and think about that for a minute. And if we did this, then what is this problem if we worked it out? Well, it would be 8 times 125 times 8 times 125. Well, what is that? 8 times 125 times 8 times 125. Could we reorder this and get 8 times 8 times 125 times 125? And now we can see very clearly that these two are equivalent. So now looking at all these different options, what is the answer to this? And there's an easy way to do this. If you go and look at these numbers, which numbers work together well to help you to solve this much more simply than going and squaring numbers that you don't know. So there's an easy way. Go and think about that and try and do that. So if you did 8 times 125, well, then at that point you end up with 1,000. And so now that we have 1,000 squared, that's simply 1,000,000. And you can do that problem. Math has all sorts of cool little tricks, and those are the types of problems I'm wanting to show you in here, and just to get you to think about things and not just mindlessly multiply things and look for patterns. So, all right, we have now what if there's fractions? So let's look at this fraction. So if we have 1/7 squared. So when we do this, work that out and think about what a square really is. So if you did this, probably did 1/7 times 1/7, which we know how to do that. We just do 1 times 1, 7 times 7, we get 1 over 49. Now, I want you to think about why that worked, and we're going to look at another problem that's much harder. So, now that you did that, why is 7,224 divided by 12 all squared equal to 7,224 squared divided by 12 squared? Well, think about it for a minute, and then now let's look. If we have 724 divided by 12 squared, let's write it out just like we did with our previous problems. So we have 7,224 divided by 12 times 7,224 divided by 12. And now could we rewrite this? Could we go and do 7,224 times 7,224 divided by 12 divided by 12? We're dividing by 12 two times, just like over here. We're multiplying 7,224 two times, just like here. And so these multiplication and division, this works. We can just simply square the terms. But what about if we did addition? So if we do an addition problem and have 5 plus 6 squared, what do we get? Well, work that one out. Following order of operations, this becomes 11 squared. 11 squared is 121. Now, what if we do 5 squared plus 6 squared? Work that one out. So 5 squared is 25, 6 squared is 36, so and the total value is 61. Are these equivalent? No, they're not. When we do addition, we cannot simply square those terms like we did in multiplication and division. And same with subtraction. It's not going to work. So now let's do one final problem, and I'm going to draw a little grid here that's 8 by 8. So 1, 2, 8 by 8. And so I have a square. And when we talk about squares, isn't that what squares are? It's a geometry problem. So now I'm going to go and draw off a section of it. And so this 8 by 8 actually has a 7 by 7 in it. And so if we were to do this, I want you to see this kind of interesting thing, that 8 squared is equal to 7 squared plus 2 times 7 plus 1. So why is that true? Well, we had our 8 by 8 grid. We've got a 7 by 7 grid here. Okay. Now we have these two little squares of 7 strips, there and there, and one little square in the corner. And this is true for other things. So if there's squares we know, we could go and add to it just a few, and then be able to go and calculate that much easier. So using the same thought, if we have 901 squared, we could go and use the same formula. So think about what that might be, taking this idea and trying to turn it into a giant grid. Don't draw it out, please. Try it out. So what we could do is 900 squared plus 2 times, well, 1 less than what it is, which is 900, plus 1. And so we would end up with the same giant grid just like this. But this problem is going to become so much easier than 901 squared. We don't have to, we can do it in our head instead of multiplying everything out. And so we have 900 squared, we know, is 80 810,000. And then we know that 2 times 900 is going to be 1,800. And then 1. So now we just add it all up and get 811,801. Sorry, 1. And is only for decimals. So we can go and actually compute that much easier than if we did. So I hope this was interesting. We're going to go and do some problems using these same concepts as kind of a fun game in class. So I hope you enjoyed that and have a great day.